This is number 1 off the AP FRQ review worksheet for derivative graphs. This is a non-calculator question. It says the continuous function is defined on the interval from -4 to 3. The graph consists of 2 quarter circles. So there's a quarter circle here, a quarter circle here, and one line segment. G of x is defined by 2x plus the definite integral from 0 to x of f of t dt. So this notation kind of helps us see that this f is really sitting at the derivative level of g, or at least a portion of it. So we can really think of this as f graph, or we can really think of this as a g prime graph. Okay, or we can think of it as, g prime. Okay, or a variation of the g prime. For part A, it says find g of -3. So to find g of -3, we're just going to replace every x with -3 and see how that plays out. So -3 plugs in for x, -3 plugs in for the bound. This gives us -6, the first term does. The second, we want to read the graph from left to right, preferably. So the bounds are out of order, so I'm going to flip the bounds from -3 to 0. And if I flip the bounds so I can read the graph from left to right, I got to make an adjustment. So I'm going to put a minus sign, change the sign there. It was a plus, change it to a minus sign. So then we're just going to total the region from -3 to 0. So if we look from -3 to 0, these are this region is above the x-axis, and the region is covered by or bounded by a quarter circle. So a quarter circle is area of a quarter circle is pi r squared divided by 4, or pi over 4 r squared. Or my radius is 3, so 3 squared is 9. And we can replace this integral antiderivative with 9 over 4 pi, so -6 minus 9 over 4 pi. For the next part of A, it says evaluate g prime of -3. But before we can find g prime of -3, we first have to find the derivative, which is g prime of x. So if you look at our g function, we find the derivative of each term, so 2x becomes 2. And the integral of f will bring us back down to f, right? Because if the antiderivative of f is the function, then if I find the derivative of this expression, this will remove the integral and bring us back down to f of x. So that's our derivative. Our derivative is 2 plus f of x. So replace our x with -3. We get 2 plus f of -3. Now f of -3 is just the graph in front of us. So f of -3 is 0, so 2 plus 0 equals 2. For part B, determine the x-coordinate of the point at which the graph of g has the absolute max on the interval from -4 to 3. So if we want to find absolute max or absolute min, we're going to apply extreme value theorem. So with extreme value theorem, we test critical points and we test the endpoints. So we look at our graph here. Our critical point is basically wherever f or our g prime crosses the x-axis. So we know there's a critical point at -4, and there's also a critical point at 2.5 or 1.5, which is at 3/2. So we know we're going to be testing let's see, we're trying to find absolute max. So absolute max from -4 to 3. Okay, so from -4 to 3, we are not going to test -3 because -3 is where the slope changes from a negative to a positive, so that's a relative min. So we don't have to test a relative min. We just have to test the endpoints and a relative max. So we'll test -4, 2.5, and 3. So to test -4, we're going to -2. I'm sorry. It says find absolute max, apply extreme value theorem. So g prime, right? So if we want to find absolute max, we have to find critical points. Sorry, critical points really needs to come from this g prime, wherever g prime is 0. So if we set g prime equal to 0, we get 2 plus f of x, and we're looking for where is f of x equal to -2. Our f of x is equal to -2 whenever our graph is at x is at 2.5. Okay, so at 2.5, we're heading, or that's where we have our f of x equal to -2. So we're testing -4, 2.5, and 3. So if I want to find g of -4, I'm going to plug it into my g of x expression. So g of -4 is equal to 2 times -4, integral from 0 to -4 of f of t dt. If I want to evaluate 0 to -4, I again want to read the graph from left to right. So I'm going to flip the bounds, becomes -4 to 0. And if I want to total the region from -4 to 0, that's going to give me 9 over 4 pi. Minus pi over 4. -4 to 0, my bad. -4 to 0 also includes this region here. So we have negative pi over 4 and we have 9 over 4 pi. We total those together and we get 8 over 4 pi, which is 2 pi, or -8 minus 2 pi. At 2.5, we're going to plug 2.5 in for the x's, and 2 times 5 over 2 is just going to give us 5. The integral from 0 to 2.5, let's see, the integral from 0 to 2.5 is going to be 9/4. Okay, so 9/4 there. So 5 plus 9/4 will give us 29 over 4. For g of 3, we're going to plug in our g of x function, into our g of x function. So 3 plugs in for x, integral from 0 to 3. Okay, that's going to give us 0. So the integral from 0 to 3 will give us 0 because this region and this region will just cancel each other out. Okay, so we're just left with 6. And if we compare 6 with 29 over 4 with -8 minus 2 pi, our absolute max is going to be at 29 over 4. That's the largest y value. And for part C, find the values of which our graph has a point of inflection. So point of inflection, if we're looking at a G prime graph, a derivative graph, point of inflection are going to be the peaks and valleys. So the only peak that we see, or between peaks and valleys, the only thing that we see is a peak, and that is where our G prime graph changes from increase to decrease. So there's a point of inflection for the original graph of G at 0. Okay, so point of inflection at x equals 0 because f prime changes signs. F prime changes from positive to negative. Let's see. Part D, find the average rate of change. So the average rate of change is the change in position over change in time. So we can just find the y values and the x values and subtract it. So change in y over change in x between -4 and 3. So we just take those order pairs and we just find the slope. So -3 minus -1 over 3 minus -4. And that gives us -2/7. There is no point with slope -2/7. Right? It says there is no point for which f prime is equal to the average rate of change, and explain why this does not contradict the mean value theorem. And the reason why, normally we can say that whatever slope is between the endpoints, there must be a guaranteed slope, specific slope, somewhere between those endpoints. However, that's only going to apply, that's mean value theorem, but mean value theorem also states that the function needs to be not only continuous, but also differentiable. And we see that there's a place where our f prime, our f of x graph is not differentiable. It's not differentiable at x equals 0 because there's a sudden shift in the slope. This looks like it's moving towards slope of 0, and all of a sudden it changes to a negative slope. So there's a sudden turn, sudden change. Our function is not differentiable throughout the entire interval, specifically at x equals 0. So therefore, mean value theorem does not apply.